Hello, my name is Dan Oak and I'm a student at Athabasca University, currently taking the course Computer Science 444, Embedded/Robotic Programming, Revision 1. And if you've been following the videos I've been posting to the course forum so far, you'll know that I'm going through the SparkFun Inventor's Kit Guide, and I've got some video series out there showing me completing Project 1 and Project 2, and for both of those I not only completed the basic circuits associated with the guide, but also I did the coding challenges associated with those projects as well. And in the last video, I started to go through Project 3, specifically Circuit 3A, dealing with servo motors, which we'll just jump right to there on page 60. However, in the last video, my computer had apparently got unplugged and shut down right as I was going to show the live demo. So I'd already went through the video and explained some of the concepts associated with servo motors and the circuit, as well as I went through both the Arduino code associated with the original circuit that SparkFun provided on their website, as well as the code that I created for the coding challenge. So, and then I was just about to show you the demo, and that's when the computer died, and then I also had to take my kids to jiu-jitsu, so it's been a little bit. Although, in the magical world of clicking a video online, if you watch that previous video, you'll immediately be where you are now, which is ready to see the continuation of that. But again, we're going to go through the 3 coding challenges. Again, the original circuit, basically you control the position of the servo based on the potentiometer. And the coding challenge wanted us to reverse the servo direction. So try making the servo move in the opposite direction of the potentiometer. So we're going to do that. We're also going to change the range by trying to alter the map function so that moving the potentiometer a lot only moves the servo a little, or vice versa. So basically I can go from one extreme to the other on the potentiometer, going from 0 to 1023, 1023, and it'll only move the servo motor like from a range of maybe 80 to 110, as opposed to the regular range of 20 to 160. Again, most servo motors have a range of 0 to 180, but we typically don't want to go the full range because otherwise the servo motors might start acting shaky or just in general have a little twitch to them. So we typically have brought those ranges in a little bit, and the original circuit range has the potentiometer control the servo motor from a range of 20 to 160, and change the range will just reduce that to 80 to 110. And then finally, we're going to swap in a different sensor. Instead of use the potentiometer to control the position of the servo, we're going to put in a photoresistor circuit instead of the potentiometer, and we're going to use that to control the servo motor based on how much ambient light is in the room. So that's the coding challenges. Again, just a quick recap. In the previous video, I have went through this code already. So this is the code I created for Circuit 3A coding challenge. And so we'll just restart it. The code's already uploaded, but we'll just upload it again. And so in the serial monitor, I'm outputting, telling the user to enter, default, reverse, rescale, or light to switch modes. When the program starts, we automatically enter into default mode, as you can see here. And so default mode is where the potentiometer directly controls the servo motor. So again, going all the way to 0 on the potentiometer puts the servo motor at an angle of 20 degrees, and going all the way to the other end on the potentiometer has the servo motor go to an angle of 160 degrees. And I'll show that code right here. So again, if we're in the default mode, current mode, default mode is case 0. Again, the servo position is we're mapping the potentiometer value, whatever we're reading on the potentiometer pin, which is normally going to be between 0 and 1023, and we're going to map that to the servo minimum value and servo maximum value, which those constants, as you can see above here in the code, are 20 and 160. And then when we rescale them, they're going to be 80 and 110. But the default servo min and max are 120 and 160 respectively. So that's what's happening there. We're in the default mode. Now if I type in a command such as reverse, and it doesn't matter if they're all lowercase or a mixture of lowercase and uppercase, it's case insensitive, but if I type in the word reverse spelled correctly, it'll put it in reverse mode. As you can see, it showed up here now in reverse mode, and it only prints it once. I ran into all of my issues with this code, and the thing that took me the most time troubleshooting was actually getting this serial monitor stuff to work, so that when I switch a mode, I only write it once in the serial monitor and don't have it continuously write. So now it's in reverse mode. So as you can see, the potentiometer is all the way to the maximum value, which would be reading 1023 on the analog pin. But the servo motor is at the 20-degree angle, so the opposite of what we think. So then if I turn the servo motor all the way down to 0, now the servo motor is at 160 degrees, the exact opposite of what it is in the default mode. And I'll go back in the default mode so you can see that. So I typed in default. Now you can see I'm now back in default mode, and the servo motor switched to match what it is now because I'm at the 0 spot. And again, now it's following exactly what I'm doing as opposed to the reserve mode. Also, I can go to the rescale mode. So rescale mode now means that if I turn the knob of the potentiometer from one extreme to the other, the most I'm going to turn is a little bit. I'm going to go from 110, which it's currently in because the potentiometer is all the way up at 5 volts. And if I go all the way down to 0 volts for the potentiometer, I'm only going to go to a degree of 80. So all the way down, and I barely moved the potentiometer, the servo motor. So again, I'm turning the potentiometer all the way from one extreme to the other, and the servo motor is barely moving. That's in the rescale mode. And then, last but not least, there's the light mode. The light mode means the potentiometer is no longer doing anything. So that kind of doesn't show it very well because I went to show something with the potentiometer and it moved, but it's not the potentiometer, it's the photoresistor. The voltage circuit I have here. So as I cover the photoresistor and make it darker, that's changing the position. Maybe if I add some light, so I turn on the light, a lot of light is coming in, meaning there's not much resistance on this photoresistor, therefore the voltage being read on this analog pin 3 where this yellow wire is going is there's not very much resistance on this, so it changes the voltage reading, and you can see the position of the servo motor, but as I make it darker, I'm changing the position. Now again, it doesn't seem to be changing by that much. That's not because of the range. See, now it's changing more with the light off. But one thing you might want to do that I didn't do, so if I look, I'm in light mode here. So in case 3, where I'm not reading I'm not reading a potentiometer value anymore. Instead, I'm doing an analog read of the light pin, not the potentiometer pin, and I'm assigning that to light value, and then I'm mapping that light value, meaning the value read in from the photoresistor circuit here. I'm mapping that from what I should be reading in, which is 0 to 1023, because that's the range that we can read on the analog pins in a microcontroller. And I'm mapping that to the regular min and max values of the servo motor, 20 and 160, but I might not be getting the full range when I go from bright light to complete darkness. It looks like I'm getting most of the range, to be honest, but I might not be getting all the range. If I wasn't, it would be something you'd have to adjust with the thresholds. So if you watch the previous video that I had on the photoresistor, you'll know that the threshold of the natural reading that you'll be reading off of your voltage divider circuit with your photoresistor is going to be different depending on the room you're in, the natural ambient light in the room, or the artificial lamps and lights you have going on. So what you'll do whenever you have one of these circuits is you'll actually want to see what the ambient reading is when nothing's happening, and that kind of be your middle point. And then you'll want to see when you turn all the bright lights on that you have, when you have as much bright light as you have on the area, what the max reading you're getting on the analog pin is. And then when you have it really dark and you've got your finger directly over the photoresistor, what reading that is, and that would be the actual values you'd put in here instead of 0 and 1023, because we may not be getting that. And that way we would actually be fully mapping from full brightness to full darkness, and we get the full range. But in this case, it seems like it's pretty good, so that's not really the purpose of this video. It's just to show that you can use different sensors to control servo motors. And then, so yeah, that's pretty much it. So again, one of the things I did was, if you're already in a mode, like right now I'm in light mode, and you try to re-enter light mode, it doesn't do anything. It doesn't output some text to the serial monitor saying light mode. It just keeps you in light mode. It doesn't matter how many times I try to re-enter light mode, I'm still just in light mode. It only writes something to the serial monitor if I enter a different mode, like rescale. Okay, I misspelt rescale, so it gave me this invalid command: enter default reverse rescale or light. So that was just me misspelling rescale. But there, I entered rescale, now I get it output. But again, if I try to re-enter rescale again, nothing will happen because I'm already in rescale mode, as you can see by the serial monitor here. And the rescale, again, just means that it goes back to the potentiometer, but the full range of the potentiometer only moves the servo motor very little. And then we'll go back to the default mode. And again, this is not case sensitive, so I can type in whatever I want. I can even have white space and still press enter, and it'll still work because I'm using the trim function in the code. And yeah, that's pretty much it. So that's circuit 3A, the original circuit, just using the potentiometer to control the servo motor. So the potentiometer position controls the servo motor position via the map function. And then the coding challenges allow us to reverse the potentiometer's control of the servo motor, rescale it, or use a different sensor altogether, i.e. photoresistor or something, to control the servo motor. This kind of reminds me of that musical instrument they use in Big Bang. Sheldon plays it. I think it's the theremin or something, where you're like, okay. Yeah, that's pretty much that. So this is some troubleshooting you might have ran into. If the servo doesn't move, check the wiring on your servo and make sure that the red wire on the servo cord is connected to 5 volts and the black wire is connected to ground, and the white wire, i.e. your signal wire, is connected to digital pin 9. So again, if we look at ours, you can see that I have from the servo motor itself, it has a black, red, and white wire, black being ground, red being your 5 volt power, and white being your signal wire, and I've just reconnected them through these jumper DuPont cables and these jumper wires, and purple is now ground, gray is power, and white is still the signal. And you can see that I have the gray and purple hooked up to the 5 volt and ground rails on the breadboard, so the power is hooked up correctly, and the signal wire is in fact hooked up to digital pin 9, which again, it could be any digital pin that has pulse width modulation capability. So that could be pin 3, 5, 6, 9, 10, or 11. Again, any of the digital pins that have that little tilde symbol beside it. But so check that if you're not getting your servo motor to work. Just one thing to always check whenever you're dealing with actual circuits is wires come out easily. You might have misplaced it. I mean, they're very tiny. Breadboards, especially depending on the light you have in your office that you're working with, or if you're like me, 40 years old eyes, it's going to be difficult to see. Finally, the servo's twitching. So the servos, this is something we already mentioned, the servos are supposed to move from 0 to 180 degrees. However, sometimes setting them to their extremes the extremes of their ranges cause them to twitch. So make sure you aren't telling the servo to move outside of, first of all, its original range, but actually try not to move outside the range of 20 to 160 degrees, which is why That's what we mapped our range to in this program. So again, we mapped our values that we were reading on the analog pin via the potentiometer or the photoresistor, which we were going to read values from 0 to 1023, and we were only mapping them to servo min and servo max, which again was set at 20 and 160, so that we wouldn't have that twitching. But if we had mapped them, let's say to 0, let's just do that here for, you know, a nice little demo. If we had mapped them all the way, oh, right now I'm on the light mode actually, so that's why. So let's just make sure we're in default mode. Just take a second here. I didn't really need to upload it, re-upload it, but so I'm in default mode. So you can see it did get a little straighter. It's at the 180, whereas before it was at 120. So in this particular case, it doesn't seem to be twitching, so it seems fine, but it's possible that it could. So in this particular case, it seems good, but again, there's not a lot of signal noise here. This is, you know, fairly stable potentiometer. There's not a lot going on. If there was any signal noise or anything at all, that might be a little more jittery. It would definitely be jitter if we tried doing this. So I've made the Servo Max 185. Not recommended for your own projects. I'm just and this is good servo. It just, as you can see, it's just not allowing it to go past 180. So it's really just disregarding it, which is good. But I'll put those back. But that's pretty much it. I'll go over just one other thing because I did run into a few issues. And I might as well just let you guys know what those issues are. So again, so issues I ran into with this code challenge. So I did have a few challenges while working through this code challenge, more than any of the other coding challenges I've had. Basically, the basic circuitry was straightforward. I got the potentiometer controlling the servo, I got the reverse functionality working, the voltage divider with the photoresistor working, and even the rescale feature working right away. It wasn't very difficult. The real struggle for me came when I wanted to improve the serial monitor output. I got the basic serial monitor working right away, but as I said, I had it so that when I switched to default mode, or whenever I switched the modes, this would just be running constantly. So it would just be default mode, just, you know, scrolling forever. And then when I switched to another mode, it would just do that forever too. So it wasn't really good. It wasn't very useful. So I wanted to print the current mode, default, reverse, you know, photoresistor or rescale, only once, whenever the mode changed. So if I switch modes, it should print the new mode just once. But if I re-enter the same mode, like when I was already in default mode, and if I tried to enter default mode again, it just wouldn't do anything. I didn't want to repeat the message. This part took me about an hour and a half to troubleshoot. It sounds weird, but I was using read string until next line. I was doing some different stuff, and there was a lot of different issues that were coming into play, and it just wasn't working well. So, and I had some braces out of, simple stuff, some curly braces out of place. So I eventually just got it working. I was initially using the read string until next line in a way that caused issues. And eventually I just settled on reading one character at a time using serial.read and then updating the command from there. But it took a lot of trial and error. So again, this is what I had eventually settled on, if you remember. So I checked if there was anything available to read, and then I did serial.read. I was just reading one character at a time, assigning it to a char variable, and then updating my global string variable by that character. And then once I once there was no longer anything available to read, meaning I had reached the end of the message that the user typed in, then I would trim the string, make sure there's no white space, and then I would compare it and see if it equals default, reverse, rescale, or light, what the user typed in. And using the string method equals ignore case. So just basically compares for equality, ignoring any case sensitivity. And if they didn't type anything valid, I just told them that and asked them to re-enter. But I settled on that. I still could have, when I ended up finding out the issues, it wasn't really the read string until next line issue. I could have went back to that, but at that point I changed the code so much and I just stuck with this, and it works fine. So in the end I got it working, and my issues were all just stupid oversights, which is what happens in programming. I was doing also fielding some emails at the same time from my daughter's school, so there was just other stuff happening, but it wasted a lot of time and it was frustrating. But it's all part of coding, and especially coding challenges, which are meant to be challenging. But hopefully you got something out of this video and the previous video that associated with the main walkthrough of the circuit demo, and hopefully you enjoyed it. If you have any questions, as always, post them on the forum, and I'll be able to I'll try to answer them if I can. Thanks for watching.